Hi, everybody, and thanks for giving me this opportunity to talk to you a little bit about today about the Age of Orchestration and the coming revolution and the changes we're seeing here as a result of AI. So the subtitle is From Planting Seeds to Managing Swarms, and you'll see that I start by going all the way back to farming, and I'm like, why are we talking about farming? Well, farming is around for at least, as far as we know, for at least 10,000 years. And essentially, this has happened for a long period enough of time that we could understand the changes and how the evolution of work and how, the evolution of work of something like farming and cultivation. Farming is kind of important. We need it to stay alive. But also, we have this long period of history that we can take a look and see what are the implications and how does that look? So we'll start from the beginning. When we initially were farming and when we were learning to cultivate land, it was very much human powered, as in we started by cultivating the land, and we relied on just the basic tools and what we could do to just plant some seeds, figure out how to water the ground and all that. But essentially the key theme here, and this is not an agricultural historical lesson, but the main theme here is that we were doing this on our own. And then we learned to domesticate animals, and all of a sudden, we didn't just become human-powered. It wasn't just all about us. It was about, well, we now can get animals involved, and all of a sudden, we're able to do more. And it was wonderful, because now we took some of that labor off of ourselves. And you expand further, we built machines. I fast forwarded to several thousands of years, but all of a sudden we now had machines that we could operate, and the machines were even better than animals. So every one of these, we got a degree of efficiency. And now farming is happening at such a scale that we now have machines that operate machines. And much of farming today is happening at scale and in a very almost autonomous way, where each person is not sitting out there. The farmers are now the amount of land that they can use to cultivate, and I think there's like less than 1% of farming. So as the illustration shows here, X, 10X, 100X, 10X, but the concept is now, just a very, very small group of farmers can feed the planet. And in similar way, computing, even though computing has not been around that long, computing has very much been the same concept, is that when I started in the 90s, it was very much human powered. I probably racked and stacked hundreds, if not probably a few thousand servers over my time, ran cable under the raised floors in data centers, installed fiber optic cables, ran a lot of Ethernet cable. But essentially, it was very much human powered. If we wanted to get some work done, both from the physical level as well as whether it was inserting a CD, booting up an image, much of this work was happening at again, one human to one machine. And then the same with networking, whether networking, telecommunications, it was very much, there was always an operator at the end of the console. Y2K looked like this. I remember clearly I was in the basement of a mortgage company's data center in Simi Valley, California. American Countrywide Home Loans was the company at that time. And again, it was a bunch of systems engineers, systems administrators, and we were waiting to see what the world was going to happen when our clocks turned, and how at that point, our AS400s and some of our client-server computing was going to shift. As we got more sophisticated, we got into batch scripts. We started figuring out, like, there's got to be a better way of this relationship between computers. And also, client-server, it was one thing when you had a few AS400 systems, like these large mainframe systems. It was a very different story as the client-server computing model was taking off. We ended up having more and more and more servers, from 10 racks of, 1 rack to 10 racks, 100 racks. So we needed new ways of approaching, and how are we going to manage, administer, secure, support all this stuff. So we got into batch scripts. Then we went to infrastructure as code. So we got into things like Terraform. Puppet was an old model of scripting languages. Ansible. There was all these different frameworks and models, and the whole concept was, can we write the code, and can the code manage the computers, versus all of us trying to manage one at a time. And the big concept was, it was a big paradigm shift. It was like, what do you mean we don't log on to servers anymore? We don't log on to systems? Because the concept was, you let the software manage the systems. And we started borrowing a lot of the product development practices of checking in the code, of releasing, and the concept was everything had to be done automatic. We got into this notion of CI/CD pipelines, and the notion of continuous delivery and continuous integration was abstracting the humans and being able to log in and make configuration changes. And it got to a point where if you were doing that, it was kind of a bad thing. It was not a great thing to go do that. And what it allowed us to do, aside from we can manage many, many more servers, we can manage them in a more consistent state. We can ensure every system has a consistent configuration. And it gave us more predictability, gave us more control. And quite frankly, the systems probably stayed a lot more stable versus all the crazy changes that were happening when I was responsible for systems. And then we get into agent swarms, and we're entering this age where agents are going to help us even scale this notion of infrastructure as code is going to help us even scale it even further and almost at a grand level. And the future we're moving towards is AI data centers will be managed and run by AI. And what does that look like? And part of this talk today is really giving you a little bit of a taste of what does that world look like? And again, how is this world showing up? And how do we start preparing for that world today? So again, as just an illustration here to show the differences and how much we're able to move, the more we got code involved, and now how do we get agents to manage the code? You could just see that we're getting more and more and more scale. So welcome to the agentic age. What the heck does that mean, and where are we going with this agentic age? The real concept here is that we are all going to be responsible for managing AI agents, where essentially, again, if you looked at infrastructure as code as that translation layer, we're going to be able to communicate with agents. Agents will set up other agents, and the concept that we're going to be more or less orchestrating machines to do a bunch of tasks. And what's amazing, then the breakthrough, and I'll use the example here, whether we're talking about help desk and desktop support, is this concept of how do I give the customer experience of you are that one person that we care about, you're the one bespoke person, we're giving you a bespoke solution. But on the back end, we're doing that at scale. So a customer request comes in, whether that's a troubleshooting request, and to be able to do that very quickly, both using voice, having a lot of different endpoints, API connections, so I can look at, did you call before? What were the other issues? Have you ever had any other issues like this? I can scan knowledge base articles for the best solutions that have happened. And I can do that both at speed, both depth and breadth, and at speed that humans simply cannot. So ultimately, what does that mean is that we're able to deliver services from a technology perspective with higher quality, higher fidelity, higher security. And then the role for us is that we are managing and orchestrating these agents that would work on our behalf. So again, whether that's IT, desktop support, service desk support, how do we give the best possible service to our end users? And again, leverage this amazing power to really give so much focus on each individual who's calling us and has issues. In a similar fashion, network operations and network engineering, to be able to have AI agents scan, understand all of the configurations, understand all of the network map, and looking at that network map, the network topology, the architecture, the design, the configuration, and almost be able to help us assess and make changes and remediate things at that level of scale in real time is really what the vision of the future would look like. While we in each one of these disciplines, as I'm going through them, while the humans have a lot of expertise, it's the human expertise plus the idea of this agent swarms is where we're really going to be able to get incredible outcomes. And again, both speed, scale, ability to look much, much further out is really where the promise of these capabilities look like. In security operations, I think this is, maybe for the first time in a very, very long time, I think we're finally going to have a chance to be able to fight the bad guys and not always be outgunned and outnumbered like we've been historically, just because the amount of events and being able to figure out the signal from the noise and being able to make sense of all of that at the scale that we'll need to fight the bad AI. I think we're finally getting to that place where, again, having a team of agents who are supporting us, who again are looking at all of these different areas. So you're looking at all of the logs coming in from the SIM. You're looking at what's happening in real time in production. You're also looking at any configurations or changes. Any configurations are changing. And again, how do you quickly be able to filter all of the noise and really identify the signals? And then are you able to pull in the right tools and execute the tools at scale to both troubleshoot, diagnose, and really identify, okay, is this a false positive? Is there something real here? How do we escalate this? And to be able to triage that at scale is going to be absolutely kind of one of probably the biggest changes that will be able to impact security teams today, because I've yet to meet a security team that tells me how overstaffed and well-staffed they are, and how everything is great, and how every tool does not send them a bunch of alerts. So we're finally going to be able to use all this incredible amount of digital intelligence and compute to actually help us solve real problems today. So my thesis so far, if I've been building into this, is that in the future, there's really going to be one job title, and the job title is going to be simply an orchestrator of agents. Now, what your AI agents are going to do versus what my AI agents are going to do may very much differ. But while they may differ in disciplines and focus, because my expertise might look different than your expertise, the idea is that we're all going to need to have the skill set of orchestrating agent swarms. How do you get so many different capabilities working to support you for whatever you need throughout your day? This will probably be one of the biggest changes, almost going back to farming, the biggest changes from being human-powered to animal-powered to machine-powered. We're going to need to learn and develop our skills to work in an agentic world. And how fast or how slow that shows up, how fast or slow that shows up in your world, how fast or slow that shows up in a particular company, all these things are debatable. What is not debatable is where the future is coming, where the future is going. There's that famous quote, "The future is here, it's just not evenly distributed," is very much the same here, is that there are companies doing incredible stuff in specific areas. I think software development probably has the lead on all of us, because software developers are already using coding agents. A lot of this stuff is already happening, and it's happening at scale. So now I want to just shift a little bit and spend a few moments on the last few moments before we turn into some Q&A, just around how do we think about this from a security perspective, because ultimately, the more autonomy, the more capability, the more power these AI agents are going to have, the more we're going to really need to think about how do we secure these interactions, and how do we ensure that we're validating it. So the mnemonic here is harness, just a way of describing the kinds of security tools. This is not meant to be comprehensive. It's just to get everybody thinking about the kinds of security frameworks, security tooling. There's a host of startups looking at this space. And harness is really simple: human in the loop. We need to have human in the loop in the right places, auditability, role-based access, especially as it pertains to non-human identities, non-destructive defaults, and escalation paths, and then finally security testing and ongoing persistent security testing, and then finally, how do we scope these boundaries? So again, it's just a way of thinking about, in order for us to live happily and be able to work well with all of these agents that are going to come, we got to be able to think about the security controls, and use something like a harness model as a framework. So again, human in the loop. And the main thing I just want to highlight about human in the loop here is really ultimately we want to put, and this is really finding this magical moments. Where do you put the humans in the loop and where do you not? So right now, in much of the work that I see, sometimes either humans are in the loop a little bit too much, so then all of a sudden we get fatigue and you're just approve. Or the AI agent is running for too long without enough constraint and without enough human in the loop. So this is an element that is really, a lot of it is really figuring out where's that sweet spot. And again, the industry is still working through this. The second area is audibility. This is going to be so critical. And when done well, we'll be able to see every interaction, every character, every part of what the AI thought, what the AI responded to, how it responded. All of that stuff should show up in our audibility logs. And so much of the orchestration, so much of the learning will be able to follow our ability to, given our ability to log, is going to be our ability to make sure that agents actually learn from their experiences. Role-based access, especially with non-human identities, is going to be absolutely critical. We're going to need to get very surgical and precise about who has access to what, by when, what access gets privileged, what access does not get privileged. And this entire space is going to be really, really critical to the success of how these agents are able to be productive. So again, it's all about the sweet spot of, I need to give them enough access to be able to operate with a right level of autonomy. And at the same time, not over access or not under access, because if they don't have enough access, they're constantly coming back to you. It's like that employee who starts the first day of work, they don't have any access yet, and they're coming to you every 5 minutes. Would not be useful. At some point, you're like, okay, this is I'd rather just do the work myself, right? So again, all of these elements, they're all emerging. Everybody's still trying to figure out how to create the right frameworks. Again, there's a ton of startups trying to figure out that space. Non-destructive defaults, essentially, we want agents to make sure that if something goes completely crazy, if there's some kind of prompt injected, we want to always think about how do we reduce the blast radius as much as possible. We can learn from, and one of the areas that I'm learning so much from is nuclear power plants and nuclear engineering, because that level of discipline, they've had to really learn how do you put in multiple safeguards after safeguards, and how do you create the validation. I think as we enter this agentic world, we're going to need to learn from disciplines where failure is not an option, where failure would be so catastrophic. And so much of the work, as we think about that, is going to have to be borrowed from disciplines and from engineering disciplines that they've thought a lot about it. And non-destructive defaults is going to be one of those elements. Escalation paths, in a nutshell, escalation paths is really all about knowing when does one agent escalate to another agent, and how does that work? And also when do you escalate to humans? It's going to be super critical there. Security testing, as back to what I was talking about, the auditing and the role-based access, all of these elements need to work in an integrated sort of way, because we need to know when something is going to change. And as we know something is going to change, how do we actually enable that? And how do we ensure that the testing is ongoing to ensure that there's really high quality and you have a robust set of agentic workflows that are absolutely done in a robust sort of way. And finally, scope boundaries. Back to this submarine concept, is we need these agents to work in tight boundaries, so that way you never have anything that could be too catastrophic. The blast radius always has to be maintained. So the concept here, again, is a little bit of this harness model of, as much as we're going to see agents doing some amazing things, we want to make sure that the innovation and what we're doing with agents is always almost the harness, or the security model needs to be the brakes, so we can go fast. And having the right brakes is going to be absolutely critical for the future that we're moving into. So let me give you a proof point. I'm going to just end with this. This entire talk came to me. I love to practice yoga. And at the end of the yoga session, there's a moment where you just rest and kind of relax. And I was just thinking about this talk, and the entire kind of flow of this talk came to me as I was thinking about it. And of course, I have Milo is my agent. Milo came from a startup that I had founded prior to joining EVOTEK as a chief AI officer. And after the yoga session, I basically picked up my phone and had this long conversation with Milo about exactly what I wanted to do and how I wanted to do it, and what we wanted to do here. So then Milo went to work. And again, back to this idea of the orchestration of agents. So I want to have Milo tell the story a little bit here. So I'm going to just have Milo tell you.
Hey everyone, I'm Milo. I'm Moody's AI agent, and I want to tell you a quick story about how this presentation was made. Earlier tonight, Moody was in a yoga class, not at a desk, not in front of a screen. He was on a mat, breathing, and the entire arc of this talk came to him. The farming metaphor, the IT evolution, the harness framework, all of it. He picked up his phone, sent me a voice message, and described what he saw in his head. From that single voice message, here's what happened. I built the storyline and the 3-chapter structure. Then I generated over 70 cinematic images. The farmers, the server racks, the agent swarms, the security framework visuals, everything you've been looking at. I wrote the talk track, the slide overlay text, and the Q&A prep. Moody selected the images he loved, assembled 37 slides, and here we are. One voice message, one evening, one human idea, amplified by a team of agents. That's not the future. That happened tonight. And that's exactly what Moody's been talking about for the last 20 minutes. The age of orchestration isn't coming. You're sitting inside it right now. Thanks for listening. Back to the human.
Okay, so thanks again for listening, and thanks for the invite. And I will now take some questions. Appreciate it.